Let's take a look at the multiple choice questions from the 2024 March exam. Question 1.1 reads, in which of the following cases is the net force on the object 0? An object which moves with a constant speed around a corner. So, constant speed. So, okay, let's read the rest. Moves under the influence of the force of gravity only. Moves with constant acceleration in a straight line. I think we can eliminate C immediately because it says constant acceleration. Or D, moves with equal displacements in equal time intervals. So let's evaluate A. It moves with constant speed around a corner. So it meets one of the criteria, which is moving at a constant speed. And we know if something moves at a constant speed, then the F net is 0. And that's because the acceleration is 0. However, they tell us around a corner. And that's a problem. Because if an object is moving around a corner, the direction is constantly changing. And since the direction constantly changes, the person in the car, or the object in this case, will experience a resultant force. So A is out. Let's look at B. Moves under the influence of a force of gravity only. So if we had to draw a free body diagram to think of this object, and if it's moving with the force of gravity only, that means there's going to be a resultant, or an F net. That's going to be pointing downward. So B is out. So by process of elimination, we're going to go with D as our answer. Moves with equal displacements. So equal displacements in equal time intervals, and we know that's velocity. So in other words, this is saying constant velocity. So that's why the answer is D. Question 1.2. A 5 kilogram block traveling at x meters per second to the right collides elastically with a 2 kilogram block traveling at y meters per second to the left, as shown in the diagram. The blocks remain coupled together after the collision and move to the right. What change in total momentum and total kinetic energy takes place in the above collision? So there are some important things that we need to take note of that's going to make this solution really easy. First thing is that it's elastic. And we know that elastic tells us that the total kinetic energy before is equal to the total kinetic energy after. So total kinetic energy is not going to change. It is unchanged. Okay? And if we look at the options, the only option where total kinetic energy remains constant is D. So D is our answer. Fairly straightforward. Question 1.3. The velocity time graph below represents an object that has been projected vertically upward from the edge of a cliff. It takes x seconds to reach the highest point above the ground, after which it falls past the edge of the cliff and strikes the ground. Ignore the effects of friction. So let's draw a sketch. There's the cliff. We project an object upward. So the starting point is going to be A. We project it upward and it reaches maximum height. We know maximum height, V equals 0. And if I read this graph, V is 0 at point B. So this point is going to be point B. Then it comes back down. And if I look at this graph, I can see that this area and that area are the same. So that tells me that point C is actually in line with point A. And then the object will go down and then hit the ground point D. So if we want to know the height of the cliff, the height of the cliff will be from C to D. But you could also say that the height of the cliff is from A to D. So in this case, two options are applicable. You could choose C or you could choose D. Okay, let's move on. 1.4, which one of the following organic compounds has a 4-mile group as a functional group? So we need to remember what a 4-mile group is. A 4-mile group is a carbon, double bond oxygen, and a hydrogen attached to it. And then you have the rest of the chain. Now, this is only applicable or is only found in one homologous series, which are aldehydes. And we know that aldehydes have a suffix of L. So all we need to do is find the one that ends in L. So butane, no, butanol. My answer is B. Okay, let's look at question 1.5. Which one of the following compounds has the highest vapor pressure at room temperature? So remember, a low vapor pressure means a high boiling point. A high vapor pressure means a low boiling point. So if they want to know the highest vapor pressure, that means they want to know which one will have the lowest boiling point. So to figure out boiling point, we need to look at the intermolecular forces. Okay? So ethane, that's an alkane, and alkanes have London forces, which are quite weak. We have ethanol. Ethanol is an alcohol. Alcohols have hydrogen bonds, which are quite strong. We have propane, which is also going to be London forces because it's an alkane. And then we have fluoroethane. Fluoroethane is a haloalkane. Haloalkanes have a dipole-dipole intermolecular force. So if we had to rank them, A and C would have the weakest intermolecular forces because they're London. So we have ethane and we have propane. Now, if we want to figure out which one is actually going to have the lower boiling point, we need to think about the factors that affect London forces. So in this case, the factor that's going to be important here is the chain length or the molar mass, right? Remember, those are factors that affect London forces. Propane has 3 carbons. It's going to have a higher molar mass. And therefore, it's going to have a stronger London force compared to ethane, which has 2 carbons. It's going to have a lower molar mass, and therefore it's going to have weaker London forces. So from all of them, the weakest is going to be ethane, and ethane is going to have the lowest boiling point. So the answer there is A. Okay, question 1.6. Which one of the following organic reactions will take place only when exposed to light? So important, exposed to light. So there's only one reaction that we learned that involves light, and that is a substitution reaction. Right? If you can't remember specifically which one, that's fine. I can show you. We'll work it out. So if you look at A is CH2, CH2. So this is an alkene. We can actually draw it. We can see it. So CH2, CH2. That's carbon double bond there. So this is an alkene, right? Remember, substitution reactions are 1-to-1 reactions, meaning you have single bonds going to single bonds. So the fact that this is a double bond means that A is out. If you look at B, B is a single bond. So CH3, CH3 is a single bond, but you are getting an alkene afterward. So that's a 1-to-2 reaction. B is out. If you look at C, C is CH2, CH2. That's a 2. That's not what we're looking for. But if you look at D, D is CH3, CH3, which is single bonds, going to CH3, CH2, Br. This is also a single bond. So the answer here is going to be D.